Every morning when you wake up and start your day, you might think the world around you hasn't changed much since yesterday, but you'd be wrong. Because while we're going about our normal day, our Earth is altering itself in ways we couldn't even imagine. We're going to spend 24 hours with our planet to watch what it's really getting up to in the course of an average day. Across the globe, a new breed of scientists are showing us our home as we've never seen it before, an Earth that is constantly reinventing itself.
Things are always active. The Earth is really living and breathing all the time.
Every second of every day, it's growing, shrinking, and moving. And each change has surprising consequences for our lives. Every hour, the Earth is making mountains of new rock.
Never gives up, just never stops.
In a way that is crucial to our daily survival. By the time you've stopped for lunch, tons of dust from the Sahara will have landed in a faraway ocean.
That dust is still coming all the time, every day.
Dust from a desert that will help give us the air we breathe. And before we go to sleep, glaciers will have changed the face of the planet and helped trigger a mass movement of animal life.
So this is enormous. This is like the largest migration on Earth.
In this program, we'll reveal the myriad of different ways in which the planet transforms itself every single day. Whoa! And how they come together to make life on our world possible. You can forget about the Earth taking millions of years to change, because it is changing as fast as we are. Quite a lot can change in a day. Families can grow, we can move house, fortunes can be won or lost. But a single day can be just as transformative for our planet. Even something we think of as solid and unchanging, like the land we stand on, it's not. Across the world, land is being made and rearranged on an extraordinary scale on a daily basis. And if you live here in Stromboli, off the west coast of Italy, you can see it happening. Here, they wake up to a new view every morning.
Poi dico, questa cambia sempre, giornalmente. Vai a lasciare, vedi che c'è un cucuzzo di lava che è sceso, passa dopo di giorni e non c'è più, e ne trovo un'altra su un altro angolo, che sappiamo che questa isola è un'isola che si muove.
Stromboli's almost continual eruptions might shake up the locals, but scientists are drawn here, despite the obvious dangers.
As a geologist, I shouldn't really be nervous. There's still something about being so close to so much heat and energy.
For geologists Chris Jackson and Giuseppe De Rosa, this is the place to study what volcanoes are really capable of.
You feel the ash raining down from that last eruption now, can't you?
Yes.
Gosh. Wow. A giant eruption there. Lots and lots of lava coming out. Huge volumes just being blown out the top.
Lava that in fact plays a vital role for all of us on the planet, because this lava is about to become land.
It's amazing seeing these car-sized lava bombs being hurled out of this volcano. Magma bursting to the surface, becoming lava, becoming rock, and ultimately becoming land. You can see all down the flanks that orange glow of lava which has just been kicked out. Over the course of just 24 hours, this volcano can throw out enough lava to fill 80 Olympic-sized swimming pools.
Volcanoes build land in different ways, depending on the type of stuff that's coming out.
Lots of different minerals in here, and this green colour's...
Yes, this is all living, yes.
The mineral content of the lava makes it behave in different ways. Basically, there are two types. The first, lava low in a mineral called silica that can build big areas of land quickly. The runny stuff.
It very quickly runs all the way down the sides and builds new land all the way around the edges.
On the islands of Hawaii, the runny stuff spills into the ocean and turns to rock, creating an average of 6 square meters of new land every hour. Half a tennis court in a day. So you have the runny lava, but there's also the sticky stuff.
It's too sticky to even come out.
Which has a higher silica content and builds land in a more explosive way.
Like, you know, some of the things that are coming out right now, these bombs of lava rolling way down the sides of the volcano and building the crater itself.
Over thousands of years, the sticky lava erupting from this volcano built this island up out of the sea and formed its classic cone shape. But sometimes a volcanic island can appear almost overnight. In 2014, this volcano in Tonga sprang out of the Pacific Ocean, building 60,000 square meters per day. Right now, as you are watching this, between 10 and 20 volcanoes are erupting, spraying out new land across the surface of the Earth, making a real difference, not just in millennia, but in minutes. In fact, in just 1 hour, the time it takes most of us to get out of the house, it's estimated the planet has made 3 million cubic meters of lava. Enough to build an island 200 meters tall. Without this process, the people of Stromboli wouldn't have a home. But then again, neither would we. Every day you have got volcanic activity creating new land. But every day you also have wind and water eroding land away. Now, if volcanic activity didn't create land as quickly as it does, then erosion would win that battle and the world would be left as one giant ocean. So volcanic activity keeps us all above water, but it's only possible because of the heat that's generated deep beneath our feet.
We have two sources of heat in the Earth. Primordial heat, and that's coming from the core. White hot, 6,000 to 7,000 degrees Celsius, so similar to the surface of the sun. Outside of that region, here in the mantle and in the crust, we also have heat that's being produced by radioactive decay.
This heat produced by radioactive decay drives volcanic activity and is best explained by popcorn.
A heavy element like uranium becomes lighter by emitting a particle from its atomic nucleus. As it does that, a burst of energy is released in the form of heat, and it is that heat that drives geological processes deep beneath our feet and at the Earth's surface.
Every time a heavy atom decays into a lighter one, there's another burst of energy. It's the very same process that we use to create nuclear energy. And it's everywhere. The smaller dark spots on this map are nuclear power plants. Everywhere else, radioactivity is coming from atoms decaying underground. And it all adds up. In just 3 hours, before you've even had your mid-morning coffee, the Earth has generated heat energy from radioactive decay equivalent to 4,000 Hiroshima bombs. That's about one every 3 seconds. So every minute of every day, the Earth changes from within. But once land is made, it doesn't stay put. As we continue on our day, it's time to see how the land is being warped and moved right under our noses. First, we have to look to the water. In particular, the tides. We're all familiar with sea levels going up and down twice a day. Well, every 12 hours, 25 minutes to be precise. But what's less obvious is that this process is changing the shape of the planet, and it's all caused by the moon.
A Lua orbita ao redor da Terra. E durante esse movimento, ela cria uma atração gravitacional que move as águas do planeta. E ao fazer isso, ela cria protusão nas águas do planeta. Isso são as marés.
Here in the Amazon, this shape change is so dramatic, you can actually see it. And they've even given it a name. The Pororoca.
O gado estão assim na beira que veio o estrondo da pororoca lá e eles vão saindo tudinho, vão.
Pororoca, meaning great roar, is in fact a tidal bore. When the tides are at their highest, the water rushes into this stretch of river so fast, it creates a wave large enough to surf. And they do.
Essa é uma força muito grande e em uma hora você muda completamente tudo. A coisa mais gostosa de surfar na pororoca é quando você consegue encontrar aquela onda que você sonhou. A cada vez que a gente vai, a gente está numa caçada.
Other than the piranhas and hidden logs in the water, this is perfectly safe. But in fact, it's not just the water that's getting pulled out of shape by the moon. We can't forget about the other 29% of the Earth's surface. You know, the stuff we walk on.
Every person knows that there are tides in the ocean. But what many people don't realize is that the moon also causes tides in the Earth, so what are called solid Earth tides.
We can now prove that the moon moves rock as well as water, causing a tidal bulge in the very land we stand on, which is up to 50 centimeters high.
Solid Earth tides, or rock tides, they can be measured with GPS. They cause the GPS stations to go up or down, and so we can measure how high these stations are rising all along the globe. And this is happening about twice per day.
Which means that in about 6 hours' time, I'm actually going to be up here. Now, normally I don't really need an extra 50 centimetres in height, but I'm embracing change today, so I'm going to go with it. You'd think you'd notice these waves of solid Earth, but they happen over such a huge area that they are imperceptible to us. But that doesn't mean they don't affect us. In fact, research suggests that Earth tides can trigger earthquakes.
If earthquake faults are really close to failing and creating an earthquake, then this tiny change may be enough just to tip that fault up to failing.
By the end of the morning, the moon's pull on the Earth has caused a half-meter wave of solid rock to travel 9,000 kilometers around the planet, and you hardly even felt a thing. The changing shape of Earth has another side effect you might not have clocked. It makes every day a bit longer. Let me show you what I mean, but I'm going to need something for this. Oh, guys, can I borrow your ball for a second? handy. Now this is going to represent our squashed Earth spinning on its axis. You need a moon too, though. Guys, have you got anything smaller? Thank you. Now, this tidal bulge stays ever so slightly ahead of the moon at any one point. The moon is acting almost like a brake on a bicycle wheel, slowing down the spinning of the Earth and making our days ever so slightly longer. Throughout our morning, the moon has been slowing down the Earth's spin with a force equivalent to 6,000 jumbo jets, and has caused a tidal bulge to travel through water and rock, lengthening our day by 47 nanoseconds. What with tidal bores, earthquakes and land waves, you might think that the moon's influence on us isn't a great one. But the chances are that without it, none of us would even be here. Because in amongst everything else that the moon does, it also stabilises the Earth spinning on its axis. Without the moon there, the Earth would be wobbling all over the place, which would change our seasonal relationship with the sun, make the climate completely different, and quite possibly mean that the conditions never arise for complex life to evolve.
Can you get the ball back?
Oh yeah, sorry. But when it comes to moving land around every day, the moon has nothing on the Earth itself. And yet our planet's work goes largely unappreciated. Well, we all know that feeling. The Earth, if it could talk, would probably agree with me. Because one of the barely visible things that it does every single day may well have given birth to some of humanity's greatest civilizations. This is the Sahara, Morocco to be precise. And in this part of the world, land doesn't just move, it can actually fly.
It's stunning, the landscape here. It's peaceful and remote, but the other way, it's dynamic. You get to experience how nature is moving every day.
Geologist Charlie Bristow spends his time trying to figure out how solid Earth can cross an ocean. The story begins on a dried-out lake bed. How dry?
It's very dry. Very, very dry.
And this isn't just any old mud. It's special.
This place appears dead. There's nothing here. It's dried out. It's completely desiccated. But the lake was here, and in the lake, there were little animals living here. Something called an ostracod, a little crustacean. They're kind of cute little things. And their remains are still there. So within the mud, there are nutrients.
Nutrients that are about to find themselves on the other side of the world.
Hello, Veronica.
Hello. I'm Veronica Janessa.
I'm Ramon Janessa.
Ready to go dive? We decided to take a trip to the Bahamas, and you know, it was a 4-day trip, and it's pretty amazing.
This was not your average father and daughter day out. Veronica and Ramon are technical divers, and we're exploring an underwater cave system, not for the faint-hearted.
Out of nowhere, you see this hole.
A small hole.
Yeah. And then it opens up to these beautiful caves with all of these stalactites and stalagmites, and it's beautiful.
Alien world.
Yeah.
An alien world.
Yeah.
Deep into the caves, something caught their eye. Something that didn't belong.
Suddenly you start to see pink.
Tints, yeah.
And red.
You would see this red dust.
It's very, very fine. I say, where's this? Where is it coming from?
The answer is far from what they might have expected, because this is exactly the same stuff as Charlie Bristow was turning up 6,500 kilometers away on his dried out lake bed in the Sahara.
Other people say, how do you know that that's from the Sahara? How do you know?
A lot of geology is detective work. So in order to link the dust sediments from the Sahara with those that have been found in the Caribbean, you can use a variety of rare earth elements found in minute amounts. They're good for fingerprinting the dust and show that the dust that leaves Africa is the same as the dust that arrives in the Caribbean.
But how does this nutrient-rich, rock-hard, sun-baked mud take off and fly across an ocean? That's what Charlie has now figured out. And it starts with the wind, which blows over this desert almost daily and is strong enough to make Saharan dunes some of the fastest moving land on Earth.
Wind usually blows from one direction, over the windward side of the dune, and then it deposits it on the leeward side of the dune. This is making little avalanches down the front of the dune. And these dunes really motor, get a really strong howling gale, and that'll drive the dune forwards, maybe over a meter in a single day. They're like the F1 cars of the dune world.
Sorry, made a bit of mess. Fast-moving, maybe, but the sand in these dunes isn't about to take off and cross the Atlantic. It's too heavy. But it is going to help send the nutritious mud in this lake bed on its way west.
On the rope. Obviously, we need the wind in order to transport it. But it helps to have that third ingredient of the sand to sand blast the surface and break bits up,
turning this mud into a fine dust. So in this hand, I have got some great big chunks of lake bed, otherwise known as brown sugar. And in this hand, I have got some lake bed that has been smashed up into tiny little bits by sand blasting. And me, I'm going to be the wind. This process of sandblasting is called saltation, and it's really the key behind launching great big chunks of earth into the sky. Carried by the wind, the fine, nutritious dust rises thousands of meters into the atmosphere, and then the trade wind carries it west across the Atlantic Ocean. NASA satellites have measured that each day 500,000 tons of it leaves the Sahara and heads west, some of it arriving here in the Bahamas.
That dust came and is still coming all the time, every day.
But most flying further west, where it finally comes back to ground and fertilizes the Amazon rainforest, the lungs of the planet.
When you have this red dust in your hand and you think about where it's come from, and just it makes you think of who else grabbed this or touched this. That's just amazing, and it's happening every day.
By 6 hours into your day, 125,000 tons of dust will have become airborne and left the Sahara. And in those same 6 hours, 25,000 tons of dust will have landed here in the Amazon. But this isn't the only place receiving a daily dose of nutrients from far away. And when you plot them on a map, they tell the story of humanity. So I've drawn a map of the world here for you. It's not my best work, but I did do it upside down. And above here, it's almost like you've got this invisible conveyor belt that's depositing this stuff in northern China, across the Great Plains of America, also all over Russia, and in Central Europe too. And it's no coincidence that these really are the places where some of our greatest civilizations were born, because the so-called lowest soil has provided fertile ground to feed all these huge populations and really to power some of our most innovative minds. Oh, I didn't think you'd mind. If wind can move lake beds and feed civilizations, just imagine what solid ice can do. Glaciers can break out the nutrients from the toughest of rocks, a process which not only changes the landscape, but helps us all breathe more easily.
They're incredibly beautiful, and when the sun lights the ice and creates all these beautiful colors, it is extremely emotional, actually, to get to work with this.
Now, when we say glacial, we tend to mean slow, but Heidi's measurements prove we've got glaciers wrong.
These glaciers can move at speeds up to 70 meters per day, so you can see the whole thing moving in front of you. This is incredible.
So what happens when a trillion-ton block of fast-moving ice meets the land beneath? There's only one way to find out. Get under one. Local guide Snorri Ernst Svensson has found a way down to the very base of this glacier in Iceland.
What a cool cave!
It's quite beautiful, huh?
That's awesome. Really stunning colors.
I like how that changes.
And you get these pockets that are formed by the wind, scallops.
It's fantastic, isn't it?
It's incredible to get access to the belly of the glacier,
Yes.
to really be inside it. You can feel that the glacier is alive here.
These cool little rocks inside.
Yes, exactly, all these little sediments and pebbles that are being carried by the ice. And glaciers are these massive conveyor belts constantly moving forward and reshaping the landscape around them. So there's a lot happening even right now, yeah.
And the clue to how these huge blocks of ice manage to move and grind down mountains is all around. Water.
So ice, when it's really dry and cold, struggles to move. But as soon as you get a little bit of water at the base of the ice, as soon as it starts to melt, then very quickly the ice can start sliding over the bedrock.
And you can even hear them moving. What you're listening to is an actual recording of a glacier as it plows its way through a mountain range.
Glaciers are very noisy. They're very noisy because actually they're constantly moving, and the sounds you can hear are really special. It can be like gunshots. It can be the ice cracking. It can be the noise of the ice against the rocks, the kind of crushing sound. And when you're quiet for a few minutes and you start really being careful and listening to these sounds, you realize that there's a lot happening.
Minute by minute, these giant blocks of ice are breaking mountains into boulders, boulders into rocks, and rocks into dirt. A global system totaling 200,000 glaciers, a combined bulldozer bigger than France, working 24-hour shifts to reshape the land. In the space of just 7 hours, if you add them all together, the world's glaciers grind out 2.5 million tons of minerals from mountains. Nothing glacial about that. By lunchtime, quite a lot has happened. A whole mountain's worth of new land has spewed from the bowels of the earth. There's also a nutrient-rich dust cloud the size of a continent that has left the Sahara and is heading across the Atlantic. And all kinds of ice and water that is slowly breaking mountains down into dirt. And the result of all that is... a nourishing mix of minerals and nutrients that fuels a whole new wave of daily change to life. Cheers. Oh, that's disgusting. These are phytoplankton, a type of plant you won't have seen much of because firstly they're microscopic and secondly they live in the ocean. There, they thrive on a diet of nutrients from the earth and light from the sun. Individually, they're small, but together they have a big effect on all of us. Take a deep breath in and out. And another in and out. One of those breaths was made by phytoplankton. Together, they create more oxygen than the entire Amazon rainforest. Trees, algae. Luckily for us, phytoplankton are one of the most abundant forms of life on our planet. Satellite imaging shows how they envelop pretty much the whole world. And they're growing all the time. In just 8 hours, over 3 billion tons of phytoplankton have been added to the world's oceans. Gathered together in one place, that's a mountain of plant life 1.5 kilometers high. And this daily explosion of phytoplankton triggers one of the greatest mass movements of animals on Earth. This happens every day all over the world, but only the most determined ever get to see it.
I'm very excited about it because it's my first time diving at night. It's a better way for me to understand the behavior.
Dr. Claire Paris-Lemouzy is a marine biologist who's hitching a ride with a group of photographers.
So you ready? Yeah, it's getting good and dark.
They're going on what's known as a black water dive. For the photographers, Linda Iannello and Noé Sade, it's a chance to capture a global feeding frenzy.
A lot of people think we're crazy, float in the middle of nowhere. It's 500 feet deep. You don't know, is there a shark out there that you can't see? So you have to be aware and you have to be careful.
These blackwater dives are a great opportunity to capture video of these creatures.
Who's going first?
If you're afraid of the dark and afraid of the depths, this is definitely not for you. The divers are floating above 150 meters of pitch black ocean, waiting for creatures to rise from the abyss. Tiny animals called zooplankton rise from the deep every night to feed on the phytoplankton that exploded in number during the day.
When I see the plankton, this incredible color and light and movement and all the energy that is there, it's extraordinary.
At first, you're looking around and you don't know where to start. There's all this plankton flying around, floating around in the water column, and they're all there to feed. It's challenging. It's not easy photography, but it's worth it.
This immense cloud of zooplankton is made of everything from larval forms of larger animals like squid and crabs and rays to fully grown creatures like sea angels.
This is my favorite shot. Very rare is a paper nautilus, also called an argonaut.
You must have been excited when
I
you
was
saw that.
very excited. I chased it to 84 feet. And this is a typical shot it wanted to give me, which is a butt shot.
I think these animals are deep dwellers, so it means that they have migrate hundreds of meters. This migration happens in the entire oceans every day, so this is enormous. This is like the largest migration on Earth.
We know of no greater daily movement of animal biomass anywhere on the planet. And as the zooplankton rise, they cause another huge daily change to the Earth. They might be small, but Claire has found they have serious appetites. Claire's research has shown that some plankton can eat as much as their own body weight in food in a single day. And to put that in human terms, that is the equivalent of me having to eat this many sandwiches every hour of every day. Can I at least get a glass of water with this? This feeding frenzy travels around the world's oceans as night falls, a Mexican wave of binge eating that never ever stops. After 9 hours, over 3.5 billion tons of zooplankton have completed their daily migration, and they've eaten around 3.4 billion tons of phytoplankton. That's almost 8 times the weight of all the people on Earth. And if life can change so much below the water, what's going on up above? Life on land never stands still, not even trees, and scientists are finding new ways to keep tabs on it and figure out what it all means to us.
I really love going into forests. Trees are, in some ways, the basis of life, and they're beautiful. That one looks good.
Yeah.
Professor Lola Fatoyimbo and David Lagomasino are tackling a seemingly impossible task.
Scan of this one.
All right.
Keeping track of all of the trees in the world.
18 meters.
I'll start the scan now.
We scan one tree from one direction.
Just like that.
Then we'll move around a little bit to another spot.
Scan 2 done.
Scan another tree, and then we stitch all those images together.
Scan 3.
And we get a nice 360-degree view of what the forest looks like.
By the time they're done with their lasers and 360-degree cameras, they've created a digital copy of the forest accurate enough to measure every tree and shrub and calculate their growth.
20 grams per day.
Every single day. There's a huge range in scales of how fast plants can grow. There's some bamboos that can grow up to 90 centimeters a day, where oak trees, on the other hand, will grow about 1 millimeter or so a day.
Driving this daily growth is a transformation that only plants can achieve, turning sunlight into sugar. That clever quirk of chemistry called photosynthesis allows plants to convert that into this. That simple process of photosynthesis is the only thing that is keeping us fed down here, the only reason why we have got energy that we can use. And if you add all the plants in the world together, guess how much sugar they make from sunlight?
Daily photosynthesis produces, hundreds of thousands of billions. That's a tough one.
Fortunately, David and Lola aren't trying to work it out alone. They work for NASA and have access to a fleet of Earth-observing satellites.
So here we're starting to see the global picture of photosynthesis.
Satellites can show us what we can't see, like photosynthesis in action across the entire world.
Earth-observing satellites are really important because we can use them to look at changes in forest cover, and they give us an idea of what's happening globally every single day.
A partnership between boots on the ground and eyes in the sky. That's how scientists like Lola and David are finally able to put numbers on the colossal changes happening on our green planet. Changes that provide us with food to eat and air to breathe. From the amount of CO2 plants consume and the oxygen they release, to the weight of new plant life that every hour brings. By mid-afternoon, when I'm taking a well-deserved nap after my pile of sandwiches and cake, scientists with satellites have worked out that if you took all the new growth in all the forests and put it in one imaginary plant, you'd get a giant tree 2 kilometers high. And in case you're wondering, the same forests have also made 180 million tons of sugar. Sweet. But there is a flip side to all of this creation. Every part of the plant, all the leaves, the branches, the trunk, the roots, all have this solar energy locked up inside of them. The problem is that process is reversible. All that energy can be released back as heat and light. This is a film about daily change. And that means destruction, not just growth. Because you can't have one thing without the other.
Hello. Hey, Mom, I just texted you a picture. I'm standing right now right in the middle of the house. They bought this house when it was built new in 1975. So they've lived here for 42 years. The file cabinet's still standing there. Super nice neighborhood. Is where I was raised. That there's going to be very little, if anything. I'll dig around here, see if I can see what I can find, and all right, love you guys.
In California, they're facing the worst wildfires in living memory.
Major Baird, this is geo-rectified, right? Can you show him where the bird is on the map?
This particular fire has grown 14 miles in one day, which relative size is about twice the size of San Francisco County.
It's down all the way into suburban areas, all the way down into cities and structures. The fire doesn't care what it burns.
Power went out. My parents are awakened by the neighbor and the police saying, "You've got to go right now." And they left my mom's car because they just couldn't get the door open easily and in a hurry. And you can see, what happened with that.
A freak event for LA, but for the Earth as a whole, this is business as usual. Right now, as you watch this, somewhere on Earth, a wildfire is raging. It's a natural process, and we've learned the hard way that trying to stop it only makes matters worse.
About 100 years ago, we adopted a philosophy where we were going to put every fire out immediately. That has led to a cumulative effect where the vegetative matter, the ecosystem has begun to build up. And it's built up for so long in so many places. These areas are essentially tinderboxes, ready for a spark.
And with 4 million lightning strikes every day, there are a lot of ways for the energy harnessed from years and years of sunlight to be let loose. Fires are an inevitable consequence of growth, an unstoppable agent of change. The problem, for us, is that we have chosen to live where fires are most likely.
People in California love the Mediterranean climate, and it's a wonderful place to live. The problem is that it's had a fire history that goes back millennia.
We know that fire is going to happen. It will burn here. It's supposed to burn here. We're just trying to do our best to contain it.
By the time most of us have completed a full day's work, wildfires have raged through 5,000 square kilometers of forest, turning to ash an area the size of the Grand Canyon National Park.
Earthquakes, fires, landslides, and floods all seem like things that we could do with a lot less of. But actually, there is a theory of evolution that says that with the right amount of change, you can create the right conditions for new life to come through. But you don't want too much disruption, otherwise life won't have a chance to get started at all.
In an environment where nothing much changes, there's less diversity of species. But throw in a bit of disaster, and it mixes things up a bit. And for the planet as a whole, disasters can clear the way for new species to emerge. Like the way that mammals could flourish after the loss of the dinosaurs, which worked out rather well for us. Over the course of our day, we've seen how Earth's constant reinvention makes our world go around. But at night, something else is revealed. Our planet isn't a self-contained system with the same old ingredients getting mixed up over and over.
We're part of a much bigger system where cosmic influences stir things up a bit.
And at the end of each day, the Earth isn't quite what it used to be.
It's quite an amazing scene to see it. The sky just goes on fire. It's really hard to describe it in words.
I can see a handful of stars, so it's kind of strange to see so much power and feel that you're part of something bigger, part of a huge nature, which is quite amazing.
Astronomer Sævar Helgi Bragason and photographer Olli Helga Myrtau are hoping to witness a cosmic light show caused by a storm in space. And if you want to know the space weather forecast, these are the people to ask.
Erupted yesterday morning, would be expected. But I'm not sure if it's going to be coming towards
The weather in space may not seem like our problem, but it can cause chaos for us Earthlings.
When activity is particularly strong, the kinds of impacts would include equipment failure, equipment damage. It can also include a blackout.
Bad space weather comes from the sun, which sends a constant stream of charged particles called the solar wind towards the Earth at up to 3 million kilometers an hour. And sometimes there are more violent outbursts that can fry satellites and knock out power grids.
This is the sun, just 15 minutes ago.
But for Sævar and Olli, a forecast for bad space weather is exactly what they've been waiting for. So they can witness what happens when the solar wind collides with our planet.
Now, the solar wind is just a stream of charged particles, and when these particles hit the Earth, they are channeled by the magnetic field towards the poles, where they excite the atmosphere.
It's time to get the drone airborne. Ready for when the solar wind hits our atmosphere to create the Aurora Borealis, or Northern Lights.
It's amazing.
It looks good.
It looks really good.
But there's a price to pay for this spectacle. The latest science is revealing how the lights are actually a symptom of a huge daily change to Earth. Hate to break it to you, but our atmosphere is leaking.
When we have the particles that flow from the sun, they not only excite the atoms in the atmosphere of the Earth, but it also causes some of the particles to stream out into space, like helium.
So when you're looking at, or rather through an aurora, you're actually looking at helium ions being lost to space.
In 2010, people were worried that our supply of helium was running out. There were even some concerned newspaper reports that a single party balloon would end up costing as much as £80, all because our helium was just floating off into space. And once it's gone, it's gone. But thankfully, in 2016, a new deposit of helium was discovered, meaning that for a while yet, the party can continue. Since you woke up this morning, about 80 tons of atmosphere have been lost into space, including enough helium to fill 800,000 reasonably priced party balloons. A kilogram every second. That's some pretty drastic weight loss. But you'll be pleased to know that the planet is offsetting some of that. As we hurtle through the cosmos, we put a bit of weight back on by picking up a few fellow travellers.
Dave, it looks pretty clear out here right now. Do you think that's going to hold for tonight?
Sure hope so. We're looking for a wonderful night under the stars.
Dave Powell is waiting on a special delivery, shipped express from outer space. Tonight is the night of the Geminid meteor shower, and there's no better way to see it than in the clear night skies of the desert with some like-minded friends.
Apparently they're happening all the time, but you can only really see them at night.
Where was it, Dave?
A lot of people think they're really big, but they're actually only about the size of a common blueberry.
Ooh. Blueberries are the size of meteors.
Whoa! That's a really good one. Every time I look at blueberries, I'm going to think that now for the rest of my life.
What? Oh, there are a lot of blueberries out there. This is what's happening during the meteor shower. The Earth is moving through space at over 100,000 kilometers per hour on a collision course with this dust.
Oh, that one? The best way I could describe the meteor shower would be that the sky is raining diamonds.
Whoa!
It's just magical.
A good meteor shower is like 60 an hour. Here we are over 100 an hour average.
Oh! I couldn't even count how many we saw tonight. Oh. Every time you switched a direction, you'd see another one. You'd look left, look right. There were points where we saw 8, 10 in a single minute. All the blueberries coming on down.
Oh, nice bright one. They're tiny, but a lot of them come down.
That's up, isn't it?
These meteors burn up in the upper atmosphere, finally falling to our planet as space dust.
There's so much of it, it adds up, making the Earth a little bit heavier each day.
And if you added up all the space dust and all the meteorites that hit our Earth, by the end of the day, you'd have a single meteorite 55 tons in weight. And there's one last change that's probably the biggest change of all, and you definitely won't have noticed this one.
As we all know, it takes the Earth 1 year to go around the sun and return to what we think is our original location. But that's not quite right. We're also part of the galaxy, which is spiraling through space at over 2 million kilometers an hour.
The actual galaxy itself is also in motion.
That means in the course of 1 day, we have moved over 50 million kilometers from the day before. So all of us are never going to return to where we were yesterday.
Makes you realize there's something a lot bigger than your day-to-day life going on here.
We're all in this together, moving forward through space.
By the time you watch this, we're already somewhere else, and also somewhere else now.
Since we woke up this morning, so much has happened. But things won't stop just because we head off to bed. While you're sleeping tonight, spare a thought for what the planet will be doing. New land will be created and tugged into day-altering tides by the moon. Lake beds will take flight and fertilize distant continents. As mountains are broken down into nutrients for the most abundant form of life on Earth. Trees will capture enough sunlight to keep the entire planet fed with sunbeams. And wildfires will burn acres of forests to allow new life a chance. And all the while, we're leaking atmosphere and careering through the cosmos. As we recharge our batteries, the Earth will still be keeping life ticking, changing enough to keep us alive, but not so much we can't survive. So be glad that it's a new world tomorrow, because if it wasn't, you wouldn't be on it.
Tomorrow, the breathtaking scenery and extraordinary wildlife of the Amazon, Earth's great rivers on BBC 2 at 9. And with penguins in Cape Town and humpback whales in Hudson Bay, BBC iPlayer explores cities, nature's new wild.